Databases is how you store information in the server or on your hard drives, and it's completely dependent on how your data looks. Hi, my name is Adi. I'm a software engineer at Amazon, and in this video, I'm going to explain how databases work in a way I wish it was explained to me. Now, most databases you interact with will be SQL databases. These structure your information into tables, like a user table that holds the email and password and a user ID. And that user ID might connect to a second table that stores the user ID and all the friends associated with it. And then each friend might have its friend ID, and then those people will have their own user tables and so forth and so on. Now, SQL databases are really good for most cases. Most enterprise databases that are like having a lot of data will use Postgres. If you need very little data and you want to be cheaper, you use SQLite, and it'll work in most cases. And it's ACID compliant, which we'll go into later. But sometimes you have a lot of throughput, a lot of information needing to be put in and a lot of information needing to be taken out. So you go to a NoSQL database like DynamoDB, which basically lets you have a key, which is like just user ID and all the information associated with it called value. And it's really fast to search up and find information, but it's not ACID compliant and it's not easier to manipulate. Now, what is ACID? ACID is atomicity, consistency, isolation, and durability. Durability just means your data is like going to stay the same even if the power is turned off. Like it won't just disappear. Isolation means that like if two programs try to access your information at the exact same time, only one program is going to get that access, so that all programs get like the information given to them, and there's not a race condition where two programs think they both manipulated the data in some way, and like there's the ground truth is not the same. Next, you have consistency, which basically means that if you have multiple databases in like China and America and Europe, that all of them have the same information. If you change something in America, China, in like Europe's information in their databases is all going to change at the same time. And then atomicity is that if your data, like if programs are running to change your data and they crash midway through, it reverts back to its last like original state. So either you have all your information that's consistent, or like you don't have it at all. And so it makes like banking really easy. And so NoSQL databases try to replicate this, but they're eventually consistent. So there's actually a delay between if your information was changed in America, how quickly it will be changed in China and Europe and all those other databases. And then after that, you're just going to have to worry about sharding, where if you are trying to scale up your databases, you might split the data stored in different servers or in different hard drives, just so you can store, like save space. And lastly, if your data is graph-based, you're going to go to a graph database. If your data is like vector-based for like LLMs or AI, you're going to go to a vector database like Pinecone. And so you're going to want to search up, based on how your data looks, what database is best for it for storing, searching, and cost. That's all there is.